All right. And again, if you need a calculator, feel free. I mean, let's not get caught up on how to do this by hand. So Danny worked 40 hours and then earned $6.30 per hour. His friend Erica earned $8.40 per hour at her job. How many hours would Erica have to work in order to equal Danny's earnings for 40 hours? All right. So we all know about hourly wages. You get your rate times the hours you work. Okay. So there's really like a setup here where Danny is earning 40 times $6.30. So we know though, and we know that Erica, for example, we don't know how many hours Erica is going to work, but she is going to get a higher rate, which means she does not have to work as many hours as Danny. Does that sound reasonable to you?
Mm-hmm.
So we know, for example, the answer is not 50, it's not 258. It's either 30 or 20. Now the rate isn't like half, or I'm sorry, it's not double. It's not double this. If it were double, she could work half as many. But in this case, we're going to find that the answer is 30. Do you have a calculator handy to be able to multiply out some numbers for us?
Yeah.
All right. Could you tell me 40 times $6.30, what that ends up being?
252.
252. And then we want this total on the down here on the bottom to be 252. We don't know the rate, but we know that if we multiply by however many hours, sorry, we do know the rate, we don't know the hours. So if we can divide that total by 8.4, we will get the number of hours. So go ahead and divide that by 8.4.
$30.
Should be 30, right? So we shouldn't be too surprised by that. We kind of knew that was the answer without doing any of the calculations, but then we have another one. So would you like me to make up another problem like this or move on to something else?
Something else.
Okay. So I'm going to do kind of another numerical analysis problem. Then we'll go to some of those awful algebraic term problems, but let me snip the answer here. Answers. It's good to kind of look at the answers as you go. That way you get an idea of, okay, on the right track or not. The gauge on a water tank shows that the tank is 1/3 full of water. In order to fill the tank, 16 gallons of water are added. So they're saying they don't know the water level, but they're pouring in 16 more gallons. Okay. And right now this thing is 1/3 full. So that's kind of the setup, the picture there. Okay. So we want to know how many gallons it has when it's full. We obviously know that it's going to be more than 16, but all these are more than 16. So again, the gauge is saying that it's full, it's 1/3 full. You add 16 gallons, and then all of a sudden it's up here, it's completely full. How many gallons of water does the tank hold when it's full?
Mm.
So this might be one to work backwards on. Right? Like if you were to subtract 16 from each of these, could you give me those values?
4.
4, 24 minus 16.
8.
8. Next one is 12. Notice there's a pattern. It's going up by 4 each time. What would the next one be?
16.
16, and then 20. So these amounts represent the initial amount. Okay. So they're saying like, hey, it had 4 gallons in it. I added 16 is 4. So what you're looking at next year is 4, this value of 4, is it equal to 1/3 of 20?
I don't know.
Okay, well, let's just keep going here. Is 8 is 1/3 of 24? So another way to look at it is like, if it's a third, if you
Oh wait,
multiply
is
this,
it?
yeah, so this one
Oh,
is the right answer, because when you multiply by 3, you get the full answer. Okay,
oh wait, how do you know the 8 is the right? Oh, I don't know.
well, it's the initial amount, so we're just working the answers backwards to see, okay, here's the initial amount. Is 8 1/3 of 24? Because 24 represents the full amount. This is called the table method, where you work the answers in a table to decide that. So 8 is 1/3 of 24.
How do you know that though? And D's the one that says 16 on it.
Right. But 24, the question is asking how many gallons of water does the tank hold when it's full? Let's just
How do
say
you,
it has. Oh, good.
how do you know that 8 or is 1/3 of 16?
8 is
Or
1/3 of 24, just
oh,
multiplying by 3. Just multiplying by 3. The 16 is just how much you add to it to get it full.
okay.
All right, let's try another one of these kind of numerical problems. All right, at a luncheon, 48 half pints of fruit juice are served. Excuse me. All right. What is the cost of $3.50 per gallon of these servings of fruit juice?
How much is a pint?
Yeah, good question. I actually don't know. Do you remember if you have to know units of measure for this test?
I I mean, probably I'm not sure. I don't know units of measure though.
Yeah, me either. But this might be something to look and to double check and see if that's there. So 1 gallon is eight pints. Okay. Now 48 half pints is really how many actual pints? It's like saying 48 half dollars is how many actual dollars is that? Have you ever had someone give you a half dollar, the
Mm-mm.
larger coin? Well, it's 50 cents, right? It's exactly 1/2 of a dollar. So it takes two of those to equal like an actual dollar. So it takes two half pints to equal one full pint. All right. So when it says 48 half pints, that's 24 pints. Okay. Oh, so we need the actual number of pints, because like you were asking, it's talking about per gallon, and well, we we need to know how many pints are in a gallon. We know that there are 8 pints in a gallon. So if you can just accept right now that, okay, it's 24 pints, well, how many gallons is that? 8 pints is 1 gallon. So 16 pints is 2 gallons. 24 pints is 3 gallons. So 24 pints is really 3 gallons. So all this work to figure out that, okay, it's 3 gallons, and we know that it's the cost. The cost is, well, 1 gallon is $3.50. So we know that we're going to pay $3.50 for every gallon. We've got 3 of them. So we're going to multiply 3 by 350. And that equals $10.50. All right, I've got
Mm,
another numerical question here. Do you want us to move to something else like geometry or?
no.
Okay. All right, it says Henry has $5 more than Oliver. Okay. And the same amount of money as Murray. Okay. Together, that sounds like that's all 3 of them. Together, they have $85. How much money does Oliver have? Okay, I'm going to actually re-snip in this question and the answers because I want to show you what's called the table method. I think you'll like it. But I need just a little bit of room because we've got to put some headers on the table. Okay. So when you read this, let's read it together again here. Henry has 5 more than Oliver and the same amount of money as Murray. Together, they have $85. How much money does Oliver have? These answers refer to Oliver. Do you see how I've come up with that? It's asking how much money Oliver has, so these answers refer to Oliver.
Mm-hmm.
What does the problem say about Henry? Henry has $5 more than Oliver. So can we figure out how much money Henry has from Oliver?
45.
Well, Henry has 5 more than Oliver. So for example, if Oliver is 10, Henry has 15. We've all, when we used to do a lot of cash, we'd stand and say, oh, how much do you have? Oh, I got 10. Oh, I've got 5 more than you. Okay, you have 15. So Henry has $5 more than Oliver. So we're going to add 5 to each of these. Okay, now what do we know about Murray? How much money does Murray have? How do you read the first sentence there? Does Murray have the same amount of money as Henry or Oliver?
Henry.
Henry. So 15, 25, 30, 50, and 60. And what do they all have to add up to? What's the total?
85.
85. So now you just have to figure out which of these 3 add up to 85.
Do any of them?
Yes.
25.
Yes. Letter C. Good. So I call that the table method. It's using the answers to create more tables to be able to answer the question rather than writing equations. All right, let's look at question 13 here. New question coming up. All right. A bed and breakfast charges $48 per day for a double room. In addition, there is a 5% tax. How much does the couple pay for several days stay? We don't know how long a several days stay is. Okay, let's assume that the several days stay is 3 days. That's the only one that makes sense in this context here. So there's 2 approaches to doing this. One is to figure out how much it is per day, including the tax. The second one is to figure out how much the cost is for 3 days, and then figure out the tax on all 3 days. They do give you the same result. which kind of makes more sense to you?
How would I start?
So there's two approaches. Approach one is to figure out the cost per day, including the tax. Okay. The second approach is to figure out the total cost, then the tax, total cost of the room. They both give you the same answer, but it's just like some people see it a certain way. Like, I want to know how much per day it is. Or no, I just want to know how much the total is for 3 days. Or do you want to see both approaches?
I just don't know how to do the 5% tax part.
Okay, so
Or
the way to do 5% tax is you take the amount and multiply by 0.05. That gives you the tax part. But most people don't actually care about the tax. They care about the new total. So to get the new total, you have to multiply by 1.05. That gives you the new total, including tax.
mm, I don't know.
You have a calculator handy to multiply these? Either
Oh
of
no,
these?
I just don't know which. I guess just pick one of the methods. I'm not sure how to do either of them.
Well, we're currently doing the one on the left. We're figuring out how much the
Oh,
room is per day, including the tax. So we need to take 48 times 1.05.
$50.4.
$50.40, but they're staying more than one night. In fact, they're staying 3 nights. So we multiply by 3.
501.2.
Yeah, 100.
151.2.
Good, good. Now the second approach is to say, okay, they stay for 3 days. 48 times 3 is $146. And then you multiply by the tax 1.05. So could you calculate that for us, please?
$153.3.
Maybe I added these wrong. Oh, sorry. 144 I added wrong, multiplied wrong. Try that, please. It should be 151.20.
Yeah.
So that's what I meant by, like, sometimes you go to the store and you don't care how much they are individually. You just care about the total with the tax. Or sometimes you're trying to decide, well, how long can I stay? So I figure out the total for each individual one, including the tax, to make that decision. Okay, let's take a look at a new problem here, something with a graph in it. Graphs are super fun. All right. How many dollars? Let's take a look here. How many dollars do the sales in the meat department exceed the sales in the dairy department? Okay, so it looks like we need the approximate and the meat and the approximate and the dairy. I can probably insert, draw some lines here maybe to help. I don't know how easy it is to see on your screen, but we can kind of imagine that's meat. And then we'll do another one for dairy, like that. What is the difference in those?
20,000.
25 minus 15, right? 25 minus 15, which is 10, but what's the units here? It's in hundreds, hundreds of the,
100,000.
yeah, so you have to multiply 10 by 100. Don't know if you would have a calculator here, but you basically just keep all the zeros. There's 3 zeros and then a 1.
Okay. So 10,000.
All right, so here's another, some sort of a graph. Looks like they'll give you pie chart in this one. It's not really pie season right now. It's at least not in this part of the country. Okay, how many dollars were spent for labor? Okay, so there's labor. Labor is 40% of the expenses. Okay, so they're saying that 40% of 240,000, 40% of 240,000 is for labor. Do you remember how to take a percentage and multiply it by a whole number?
How to take a what? Multiply it by a whole number?
The
A
percentage
percentage?
here, yeah, percentage, but multiply it by a whole number.
No.
Okay, do you remember how to convert the percentage to a decimal? To do this, you divide by 100. You have to take 40 and divide it by 100. Do you have a calculator handy to tell me what that
Is
is?
it 3?
When you divide, it just moves the decimal. So it's going to be the same, roughly the same number, same digits, but the decimal just moves. Unless maybe you're giving me the whole answer.
0.4.
0.4. So it's 0.4 times 240,000. Now this one probably would not have a calculator because you can kind of manipulate decimals not to with some ease. I won't say like complete ease, but you can go ahead and multiply these. Let's see which one you come up with.
$96.
Exactly 96 or 9,600 or 96,000.
96,000.
Yeah, there you go. Okay. I think I've got another pie chart here. All right. Here we go. Let me get some answers snipped in here as well. All right. The graphs show what happens to each $100 taken in by a small business. Okay. How many dollars out of each 100 taken in represents profit? Okay. So what they're saying is that when they get $100 in, they know that $30 go to salaries, $40 to materials, 5 to insurance, 6 to miscellaneous, 11 to taxes. But they're like, well, how big is the slice to profit? Okay. But this whole circle is, if we go all the way around, that's $100. Okay. So let me actually not, you can't see if I do that like that. If you go all the way around the circle, that's $100. So you just have to figure out what is missing if you have 30, 40, 5, 6, and 11. Basically, you're asking like, well, what do those add up to? And how much is left over for profit? And kind of just by estimating, it's basically the same size as taxes roughly. So we know it's not E and it's probably not D. Now, I wouldn't guess at this point, but you know, you could probably get it down to A or C because B is a decimal and there's no other decimals in here. But why not just add up the numbers, 30, 40, 5, 6, and 11 and see what's left over. Is it A or is it C?
A.
It is A. Good. All right, so here's another table question. We want to do this as a table. Let me show you that here. You snip in the answers. All right. Nick scored 7 more points than Josh in a basketball game. Paul scored 2 points less than Josh in the same game. If the 3 boys scored a total of 38 points, how many points did Josh score? These answers here, who do they refer to? Nick, Josh, or Paul?
Mm. How would you start?
I'm just asking you to read the question. It says, how many points did Josh score? And just tell me that
Oh,
these are the values for Josh. Because when you're making a table, you have to know, well, what does the table represent? So now let's go to someone else. Nick. What does it say about Nick and the problem?
yeah, 7 more points than Josh.
Okay, so we're going to add 5 to each of these. 12, 18, 24, 28, 34. And then last guy is Paul. What do we know about Paul?
Mm, 2 points less than Josh.
Okay, so that's 3, 9, 15, 19, 25. But their total is how many?
38.
38. So one of these is going to add up to 38. Now you can exclude a few right away. Like you obviously wouldn't start with any of the big ones. Maybe C is out, but it kind of helps you to know, okay, let me start with the ones that kind of look like they could be the right answer.
B.
Yeah, B. Very good. All right. Okay. Just looking here to see what else there is. So there's a bunch of these sort of, and I know you said, okay, we don't want to do any geometry, but at some point we got to hit on it. Here's your kind of your classic geometry problem. And I'll just show you how to do this with some time that we've got left here. Um, there's a really important equation for triangles that you want to know, right triangles. And it's the leg A and the other leg B and the hypotenuse C are related by the equation A squared plus B squared equals B squared. Okay, so what that means in words is if you square the 2 legs and add them together, that's A squared plus B squared, it equals the hypotenuse squared always. Okay, so we're just going to relabel this where this is A, this is B, and this is C. And we know that A is 16 squared, B is 12, we're going to square it. B we don't know, but we can square it. Do you have that calculator handy to tell me what 16 squared is?
How would I find the squared in a calculator?
Okay, so it's going to say something to a power of 2, or you can do 16 times 16. That'll also do it. 16 squared means to multiply it by itself.
256.
It's good. And then 12 squared is 12 times 12.
144.
144. Now, could you add those two together?
400.
400. Okay. So now to solve for C, you would have to take a square root of this number, but you can also kind of make a table here. Okay. You could take this number and multiply it by itself. 17 and multiply itself. 20 and multiply by itself. 22 and multiply by itself. Same with 31 here. One of these will be 400. So you can always work a problem backwards to find the right answer. So will you multiply these together and one of them will be 400?
Is it 20 and 20?
Yes. So there's your answer. Let's try a new problem here. I'm just going to change the dimensions here. 8, 15. See, so the correct answer is still in here. So the formula for this is if you have a right triangle, it's A, B, and C. A squared plus B squared equals C squared. A and B are the legs. The legs come out from the 90-degree angle. You're given A and you're given B. A is 8 squared. B is 15. We're going to square it. Equals C squared. So could you square both of these numbers, or like we did last problem, just multiply it by itself and then add them up?
64.
Good.
225.
Okay. Add those together.
289.
Good. Now, do any of these answers multiplied together give you 289?
Mm. B.
It's B. Very good. All right, so I'm going to go ahead and stop right here for tonight.